Hello. Hi guys, good morning. Welcome back to a new video. Ki hal chal? I hope you guys are doing good. In this, we're gonna see problem maximum chunks to make sorted. Now, it is simply saying that you are given an integer array of length n, and that represents a permutation of integers from 0 to n minus 1. As you can see, length is 5, n is 5, so it's a permutation of numbers from 0 like 1 2 3 and 4. These are the distinct numbers and it is just simply a permutation as in the arrangement of these different numbers. That is my given input array. That is a very important stuff, so make sure this is a permutation of some distinct numbers from 0 to n minus 1. Now, why it's important, I'll tell you later on. Now, we split array into some number of chunks. Chunks is simply nothing but some partitions. As you can see, I can do some chunks like this and individually sort those chunks. So I can just simply sort it. After concatenating them, which means after, okay, I did it divided into multiple chunks. I sort them. It will become 3, 4, it will become 1, 2, it will become 0. And then simply concatenate them back again. It should become, again, this final thing should become a sorted array, right? Again, sorted array, which means 0 1 2 3 4. This should be the ultimate output. So you have to return the largest number of chunks we can make to sort the array. For example, in this case, you know that if as you did the right now chunks, so obviously this made 3 4, this made 1 2 0. It is still not sorted. But the only possible way is, okay, if I take this as one chunk, then if I sort this entire thing, I will make a 0 1 2 3. So in the worst case, the answer is sort the entire array. You will obviously in any way get the answer. So 1 is actually the worst case possible. So in this also, if I sort the entire array 0 1 2 3 4, I'll get the answer. But as you can see, I can have a better answer of 4. How? I will divide the chunks as like this. This is one chunk, sorted, get a 0 1. One chunk, 2, get a one chunk, 3, get a one chunk, 4. This is now sorted. How many chunks I had? 1 2 3 4. Answer is 4. So now this is the ultimate thing. You have to find the largest number of chunks which you can do. Ultimately, let's take a simple example. 1 0 3 2 4. As you can simply see that I can have these as chunks, so it will be sorted, and ultimately I can say I can have at max 3 chunks possible. Now, the very brute force approach simply says that Aryan, I will try for all possible different kind of chunks. For example, if I have the input as 1 0 3 2 4, again I will put the chunk here. Maybe I can put it or not put it. Maybe I can put it or not put it. Maybe I can put it or not put it. Maybe I can put it here or not put it. Which means I will have at every place I will have two options. Every place I will have two options. Should I divide this into a chunk or not? And then when I have, again, obviously, let's say if I placed here, and that's it, then I will simply sort this, which means ultimately I'm sorting a total of size n, and then try to concatenate it and then see if I have achieved my 0 1 2 3 4. If yes, then this is one possible chunk variation. I will try to maximize this possible count. So what is the complexity of this approach which we saw right now? Obviously, we are trying for all possible chunk variations, which means I will try to place chunk here, which means I have two options: either place it, not place it, place it, not place it, place it, not place it. So I will have 2 to the power n operations. Then at each variation of a chunk, as in when I say variation, I mean the configuration of a chunk, I will sort it individual chunks. Ultimately, I can also say I'll sort the entire array. So it is O of n log n. And then at the same point, I will also compare the entire array with that it should be sorted. So this thing will complexity. Will it work? By seeing at the constraints, seems like it will work. But can we optimize it? Let's see how. But Aryan, why are we thinking of optimizing it? Obviously, we want to. Interview said asked us to do so. So we can ultimately see our maksat. Let's look at our maksat again. Our maksat simply was that this is given input array, this is given output array. I was trying on for all possible variation of chunks, which means, okay, put the chunk here, maybe try here. Now, after placing the chunk variation, my ultimate maqsad was to compare, okay, if this will become equal to this will become equal to this entirely thing will become equal to this post sorting. post sorting. Considering these were the elements, can't I simply say that post sorting, what will be the kind of hash for it should be equal to the hash of it? Again, I'm just thinking of in terms of how I can compare them pretty fast, right? Because ultimately, if I can compare them pretty fast, I will not be needing to sort it. That's the only idea which I am having right now. So, with that, I realized if I do a hash, then we have a very standard issue with the hash, which we have already seen in problems like Rabin Carp. What is the issue with the hash? The issue with the hash is that 221 and 113. If I take a very normal hash, very normal hash looks like addition of numbers, or you can say simple hash looks like addition of numbers. With that, the very standard issue is that some of these and these are same, but numbers are different. But this issue arises only when you could have some duplicates or some number in general. But if I ask you that, Aryan, what if I don't have duplicates? Which means I have here 1, 3, and I have, let's say, okay, 1, 4, and I have 1, 2, 3. Okay, let's say 1, 5. Then I here the numbers are not duplicate, but still the count is different. So now you might say, oh, what if the count is also same and the numbers are also different? If the count is also same and the numbers are also different, in that case, if I take the simple summation of these two, which can be called as a hash in this case, that should be also same, because the numbers are different and the count of also both of them is same. In this case, considering it was a permutation, the numbers are always different. Thus, I can apply this strategy that I can take the summation of this portion, summation of this portion. If it is matching, then I can easily say that I would not be needing to sort it. So now I have reduced the complexity by saying that I will try for all the possible variations, which means 2 to the power n, but then I will not be needing to sort it. I can simply take the summation, and if the summation matches, I am good to go, and I will good to see, okay, this is corresponding match, and I will try for every match. Okay, for all the partitions, just simply for all the chunks, simply match their corresponding summation. But again, it is still exponential. Do you want to try better? Obviously we can, and the same idea will lie here. What is the idea? The same idea is when you are taking the summation of this chunk, okay, summation of this chunk, we want what? We want greedily maximum number of chunks. We want greedily maximum number of chunks. So if I take again, if you don't know, then if you want to take the range summation, and if you want to calculate range sum very fast, then we use prefix sum technique. That's very standard stuff. So here for me the range sum is nothing but the chunk sum. So I will obviously try to calculate my prefix sum. Okay, prefix sum 0, 1, 1, 4, 6 and 10. Okay, now ultimately what is my maksad sum? Okay, let's also find my maksad. Same way, just for you to compare that if it is good or not. I also find my maksad sum. It is 1, 3, 6 and 10. Now, your ultimate maksad was that you will try as many, or you have to find out as many chunks as possible. So isn't it very obvious that greedily I should go ahead with finding the first prefix sum which matches? Because this first prefix sum says, of 1 says that from here up till the super beginning, the sum is 1. This also says from here up till the super beginning, the sum is 1. So it is obvious that I should place one of the chunks here. So rather than trying, earlier I was trying 2h power n. Earlier I was trying for different possible chunks. But now in this case, I greedily said, okay, because I want to take the maximum number of chunks. So the first occurrence where the sum is same, that defines that this entire portion of sum is also same, which means that number are same. Or I can say after sorting, they will become same. Now, what is the next location? Next location, you might say, Aryan, I will take the next location. Next location, the summation, which is 6. But Aryan, this 6 indicates that from that sum from here to here, sum from here to here is same. But Aryan, technically, I have already placed a chunk here. So isn't it that I should say that sum from here to here I'm concerned about? Yes, true. But don't you think that, okay, if the sum from, like, if the sum here is same, sum here was also same. So if I'm saying, okay, sum is 6, which means from here to here, which means from beginning to point 2 and from beginning to this point 3, if this sum is same, the beginning sum we have already seen it as same. So obviously this will also be same. Thus, we realized that this specific chunk, because of their prefix sum being same, this specific chunk are identical. When I say identical, which means after sorting this chunk, you will get this output chunk. And ultimately, simply keep on going forward. Okay. Then I will again find a 10. Okay, matching, which means this is one more chunk, which is matching. So ultimately, because of this prefix sum match, I can ultimately figure out what all chunks would be matching. Now, it was only and only possible why I took prefix sum was because the numbers were distinct. If the numbers would have been same, this would have resulted in an issue. In that case, I would have to use a actual hash function. Actual hash function. Now, actual hash function simply represent that, okay, there is a standard technique of multiplying with some number and taking the modulo with 189 plus 7. Now that some number varies, like some people take 31, some people take like 237, and again there are multiple numbers which we can take. So this is that in these scenarios you have to take the actual hash function, but here the numbers are distinct, and also I'm taking the frequency also. Again, numbers are distinct and also the count of numbers, so there is no possibility of any overlap at all. Thus I can take the simple summation as a hash also and compare them, and that's the reason what we took and got the answer. So with this strategy, you will only take the prefix sum. Now, one very naive way to compute prefix sum is just pre-compute it, but as you simply see that it is not required. Why? Because simply you will this is your input array ARR. You will simply iterate on your input array for I equal to 0, I is less than n, and I plus plus. You can parallelly on runtime compute this prefix sum and say, okay, prefix sum plus is equals to ARR of I. And this is also for the sorted array. This is the prefix sum which my maqsad is. So I'll say sorted prefix sum. I will compute it by saying plus is equals to I. So ultimately at any step, if these two variables are same, it will indicate that my sorted prefix sum and prefix sum at that point is same. And I will just simply, whenever these two are same, which means if my prefix sum is equals to my sorted prefix sum, I will increase my chunk count. That's it. Cool. Let's see the code. It's very short and simple. I will take the chunks, my prefix sum and my sorted prefix sum as variables. Then I simply iterate on all of them. I'll just get the count as I showed you. If it is same, then simply increase the chunk count. And that's my final answer. Because I'm simply iterating on all the elements just once, time is O of n. I did not take any array as such, so space is O of 1. Because I just took two variables. Or I should say three variables, like three variables. And that's your answer. Cool. I hope you guys got it. I hope you guys got that how we went ahead in actually thinking of that we can take. Again, there are multiple variations to actually hash it. You can take maximum also, because again, these all, again, when I say hashes, these are kind of variations of how you will compare some chunks. And again, there's possibility of taking maximum, like you can take suffix also, you can take prefix also. There are multiple ways because the elements are distinct. That is the only case. And again, the count is also same. When I say count, which means I'm comparing equal count, and this equal count, which means here the count is 2, here the count is 2, and the numbers are also distinct. Only in this case I'm able to compare it. Cool. Bye bye, take care. Do make sure to join Discord and Twitter, sorry, Telegram.